Hey guys, Buildzoid here, and so I had a thought, and the thought that I've had is how much power do the E-cores pull, like when maxed out on a 13900K, right? So here I have some settings that are left over from me trying to max out Cinebench on the 13900K with both the P-cores and E-cores enabled. So we're just very quickly gonna ditch the P-cores. I can't believe I'm saying that. But basically what I'm wondering is like, are the E-cores able to pull more power than a 5950X? Right? That's the thing that I'm wondering. Because I think they do. Like, I really think that there's a decent chance that they pull more power than a 5950X. We're just gonna drop the P cores to like 3 gigahertz or something. We don't. Let's go 2 gigahertz. There. Oh, and drop the BCLK down to 100. And we're going to skip memory training. I don't feel like waiting for it, so we're just going to enable fast boot. Anyway, so I currently have the current clamp on the 8-pin, and I only am using one of the 8 pins right now. Now, obviously, this doesn't account for VRM power losses, but this is a 8-layer, like this motherboard has an 8-layer PCB. Actually, the motherboard I'm using is a Gigabyte Z790 Aorus Master. It has an 8-layer PCB. The VRM is, I actually don't know what off the top of my head, but I'm going to guess it's pretty substantial. So the VRM power losses should be minimal, somewhere in the range of like 10 to, like, yeah, somewhere around 10%. And since we're not running the P cores, there shouldn't be that much power that we're pulling right now. Anyway, so I am going to just use... I want hardware info, and actually, do I want Cinebench R23? It'll be fine. So, I want to set the affinity, and we're just going to mask off like that, right? And that should be 2 through 17, because there's a hyperthread in there. And preferences... Custom number 16. And we're going to have to check hardware info that I actually set this up correctly. Let's start that. Oh, it crashed. Well, damn. Okay, we're just going to use XTU to downclock the E-core. So 4.8 apparently won't run. Even with the P-cores disabled, they won't do 4.8. The P-core got lit up for some reason, which is weird. Advanced tuning. Let's just quickly drop the ratio to 47. That should be stable. Oh, I don't have the affinity masked off. Well, whatever. Let's try it. And we're pulling 13 amps. So, I mean, it is also hitting the P-core right now, which isn't ideal, but that P-core is running at 2 gigahertz. It's contributing minimal amounts of power consumption. So, the E-cores, like, they're pulling 13, so that's 13.5 amps times 12 volts. Just going to pull up the calculator here. Where's my calculator? Oh boy, I have so many windows open on my main system. That's not a bad score, actually. 20,000 points. But anyway, so 13.5 amps times 12. It's 162 watts. They literally pull more power than a 5950X. Actually, no, it's about the same amount of power as a 5950X. And admittedly, there was the one P-core was like helping. So we're gonna do something about that. What does a 5950X do in Cinebench R23? I don't actually know. I like the reason why I don't regularly use R23 is because I don't, off the top of my head, I don't really know how CPUs are supposed to score in it, so I have to look that up. Please tell me that synthetic. Okay, no, that's rendering. Oh, that's R20. No. Fine, we'll run R20 because I don't know what a 20,000 in R23 is. Actually, I can just mask the affinity with Benchmate. There we go. So we're going to go... well, we're going to set the priority back to normal. I kind of need to go quickly because otherwise the current clamp's going to turn off. Set affinity... Wait, what? Only... No, this is stupid. Okay, so I do have to manually mask it off with Task Manager. That's annoying. Where's my Cinebench? There's my Cinebench. Set affinity. No, I'm doing it wrong. Okay. And now it shouldn't run on all of the core, on all of the threads. Let's pull up hardware info. Run R20. And there it goes. And I think I masked it correctly. I honestly kind of can't see. Why is the P-core getting lit up? Like, why is the P-core at such high CPU usage? That's so weird. It's not supposed to be. Oh, why does it unmask itself? Okay. Oh, I just can't change the Cinebench affinity. Well, that's really stupid. Oh, I think Benchmate might be blocking it. Let's try close Benchmate. Okay. No, okay. No, I just can't change the affinity on Cinebench. Oh boy. Yeah, so we'll have to run it with all threads, because... Like, I don't... Yeah, okay, well... And the P-core at 2 gigahertz isn't going to be contributing a non-existent amount of performance, so... Like, it's still going to help quite a bit. Anyway, so that's back up at like 13.5 amps. And this is the other reason I don't use R23 very much. Like, it's the same thing as R20, as far as I can tell. In terms of power draw, it's basically the same thing. So... Anyway, we're still seeing about 13.5 amps, so that 162... 162 watts on 16 like, yeah, I know there's one P-core mixed in, so we'll take away, like... And they're slow. Yeah. I mean, you know, maybe it's because I have a bunch of stuff running. Let's give the E-cores the best chance they can get. Set them to run high priority. I might not be optimized on the voltage right now. That's another concern, is like I might be running way more voltage than actually necessary, but they don't clock any higher than this, right? Because they crashed. Oh, and they crashed again. So actually, I'd say the voltage is pretty freaking minimized considering that just died. So yeah, E-cores pulls more power than a 5950X. Scores worse than a 5950X. Oh, like, to be fair, like if you overclock a 5950X, it becomes like a 200 watt CPU, but in terms of like performance per watt, what was it, like 8,500 points or something? Actually, it was like 8,000 points. Yeah. Um, Divided by 162. So that's like, it's like 50 points per watt. And that's including that one P-core hanging out in there. Whereas a 5950X gets like 10,000 points at, 100 and like, because if we were measuring off of the 8 pins, it would probably be pulling similar power. So like 100 and I don't know, 55 or you know what? Let's give it the best chances because like the thing is, it's just outscoring them anyway. Um, yeah, E-cores are truly very very efficient devices, and also if you really push a 5950X, you can get like 12,000 points at around like 200, 250. Which admittedly, like that's going to work out for worse efficiency, isn't it? Yeah, that's slightly worse. So, anyway, if anybody was wondering if the E-cores are able to pull more power than a 5950X at stock settings, the answer is yes. Yes, they can. Or actually, I wouldn't say more because there is that one P-core, and even at 2 gigahertz, like it's still going to be pulling some amount of power once it's running Cinebench. Yeah, so like 16 E-cores versus 15950X, 5950X wins. So anyway, and that's similar power consumption too, which is like kind of like that's the crazy part to me. It's like they pull so much freaking power. Right? Like they really do. To be, I guess, fair to Intel, they probably pull less power than if they added like 4 more P-cores into the CPU, because, yeah, like, probably, like, in terms of boosting the Cinebench score per watt, I think this works out better than having 4 more P-cores, but, yeah, like, if you're running your E-cores like this, it's not efficient. Like, that's the main thing we've learned here is, like, yeah, if you push the E-cores to their limits, they pull about as much power as a 5950X. They score worse than a 5950X, and that's about it. That's the main thing we figured out here. Actually, they kind of score like a 5900X, I think, or worse than a 13600K, while admittedly pulling less power than a 13600K. But yeah, I thought this would be just kind of a silly, fun thing to try because, you know, it's 16 cores versus 16 cores, and I guess 16 E-cores is more comparable to like a 3950X in terms of performance and power consumption. Like the power consumption's still the same. It's just mainly the performance that would be a bit lower with the 3950X compared to the 5950X. So yeah, anyway, hopefully you found that somewhat interesting. And also, like, E-cores pull a lot of power. Like, yeah, especially when you have 16 of them. Which is just, yeah, like, it's a lot of silicon with a lot of transistors. It's going to pull a lot of power, especially if it's actually, like, clocking somewhat decently, right? Like, 4.7 gigahertz isn't exactly low. Yeah, the power draw ends up being like for something that's called efficiency cores, that's a lot of power. You'd think that you'd have some like crazy, low power consumption or something. Admittedly, like we are maxing them out about as much as possible, but even then, I do find it kind of funny. And it's like, yeah, you can shove 100, like you can shove an entire CPU worth of power through the E-cores, which yeah, like there is a lot of them. Like it is very simple. There's a lot of E-cores, so they pull a lot of power. Actually, how much is the per core power? Because it's like 10 watts per core, isn't it? Yeah, it's something like that, because we're pulling like 160 total. Which isn't that much. Like, high performance cores will regularly pull like 20. Actually, the P cores from Intel will quite happily suck down like 60 watts a core. Um, so, yeah, compared to the P cores, the efficiency cores are efficient, but um, once you slap 16 of them onto a CPU, like that does just kind of does like there's just a lot of them. So they do end up pulling quite a lot of power in the end. Anyway, that's it for the video. Hopefully you found this somewhat interesting. And that's it. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. And I also have a Bandcamp if you're interested in listening to industrial noise. There's a link to that down in the description below as well. And that's it for the video, so thank you for watching, and goodbye.